So this week I want to do something a little bit different, and I want to dive into the workflow that I'm using to make some of the assets, some of the content for my game. So if I jump into TrenchBroom right now, I have this enemy, and he's low poly. He has baked lighting, a baked texture, and this was all made in Blender. None of it was done using Substance Painter or any other program. Is all in Blender, and none of the texture was painted by hand. And so I'm going to just show the workflow I use to get a high poly multi-material and multi-object character from Blender into Quake with a custom palette. So right now we have this guy, he's green. I'm going to, just for example, going to make him red. So right now I'm looking at my highest detailed model. He's in a box with light volumes on every side. Sort of show the settings I have for these. Should be all the same. And right now we're in the material mode, so we have the scene lights and the scene world enabled. And I'll just show, that's our high detailed guy. And then I have my lower detail guy. As you can see, he has that high resolution baked texture on him. But it's all one material. That material 008 with the new high res texture. If I just change him to red, this is what he looks like. It's all one material. About 650 triangles. We go back to new high res. That's what he looks like after baking. And in order to make this bake, I have to have everything I want in the render to be visible. So all the lights, the sun, the guy that's getting baked to, and the guy that's getting baked from. And it has to be all in one object. So I have these additions. His buckles that he's wearing are separate objects. And those are, if I go into modifiers, I have booleans, union booleans. What that means is it's just adding the buckles to the model as if they were a single object, so it will appear in the render. So if I select the detailed and control select my 600 polygon dude and go here into render, I can have my render engine set to cycles. This allows for texture baking, and my device is the GPU. I left most of these settings completely default. And I'm using a combined type bake, viewing from above surfaces, and I just have everything selected to active. That means that's Blender's way of saying, yes, we're baking from the detailed model to the low poly model. And for this, they have to be in the exact same pose and roughly the same mesh. I also have this 400 polygon low poly model, but it's not as close to lining up as the higher poly model. Essentially, what this selected to active does with the above surface is, my understanding is that it brings a camera sort of focus in on each surface of the low poly model. And what it sees is, if I look at this polygon of the low poly model's face, so this one here, it sees the detailed instead, and it essentially bakes everything that it sees in this area to the low poly from the high poly. So if I get that selected correctly again, other settings, I have an extrusion distance. This is something that has to be tweaked on a per model basis. Higher numbers will get certain extruded features to bake more properly, but it might have some surfaces bake improperly. And in this model, there are some surfaces that are currently baking improperly that I'm going to have to touch up, probably using Photoshop and various extrusion distances. There's also this cage mode, which I haven't experimented with, but it might solve that problem entirely. The target is an image texture, so it's going to bake this all to the texture that's active in the material on the low poly. And then I have this extend type margin. And I'm using 32 pixels, so I should explain the target texture resolution is about 10 times my final resolution, what that will be once I've turned it into pixel art. So my final resolution will be 296 by 195 pixels. Right now, I'm baking to a 2960 pixel by 1950 pixel image. And so I have that margin of 32 pixels. The margin is really important because the UV map is not going to be pixel perfect, especially once you convert everything down to a lower resolution. Those additional margins around your texture bake are going to help a lot with getting little deformities around the edges of the bake. I should start baking. But yeah, so you'll if you don't have the proper margins, you might get background color. So if the background of your texture is black, then you're going to get little black edges. If you have some other color like blue, then you're going to get blue distortions. And then you'll get some other artifacts and garbage from whatever's going on in that image. Like if you're rebaking to the same image multiple times and you're not clearing image, which I don't do, then you could get artifacts from previous bakes. I don't clear the image because I've had some trouble with that and the image resizing itself when I do the bake, which isn't optimal. Other settings I have, I just have one frame on this model. It doesn't have proper animations, but it does have a skeleton. I just haven't set up the animations yet. I'm using the Rigify plugin for that. And then I'm using the Quake one, the MDL exporter plugin for Blender. And I'm using a modified version of that that I modified myself to work with my own custom palette. So here we have our complete high resolution bake for the low poly. So use red now instead of purple. And what I'll do from here is I'll go into texture paints. You can sort of see my UV, which is not supposed to be over that. So we want new high res. And I'm going to save this image. And I'm going to call him red. Delete. Now I'm going to open that up in SLK, image to pixel. This is a great program for palletizing your images if it stops being broken. So you just set in your, well, first I'll load up the image. But you set in your final dimensions, so 296 by 195. Sample mode nearest works. I don't like RGB red mean. I prefer using CIA or CIE 76, and with no dithering for these is what I've been using. And it turns out pretty good. I gotta use my own palette. And so that looks pretty decent. I mean, there's some harsh banding, but That's partially due to the base color I used in Blender, partially due to the palette that I've made. And some of the settings can be tweaked around to improve that, but for our purposes, this is fine. Red, low res. And then if I want to see the end result of all this, I'll go out of bake and I have a guy for posing. I have a flat lighting setting, so I'll go into this guy and I'll change his material. So instead of looking at Pale Elite CIE 76, he can be, I gotta open up my image. So if I want to open up an image for Blender, add it to the project, I just do that. And then it should show up here. So red low res, and here our guy is. And this guy is ready to be exported from Blender. So you select him, make sure nothing else is selected, just the object. And you export to Quake MDL. And I can change the name of my game. And this guy doesn't rotate. He can be on the random setting. And I can do, he's a red elite dude. Export that model. And then if I want to view him in engine, what I'll do is I'll open up, I use PakScape to modify my packs. Go into models, copy this dude, just to preview him. He won't show up correctly in Quake 1 model viewer because he's in his own palette, but it's close enough. So I can replace him in, this is the one I'm using for TrenchBroom, so I always have to remember to close TrenchBroom. And this is the one I'm using for crashing my game. Open this up in PakScape. So this is my this is the directory used by the actual game when I'm test running it. So I guess I gotta rename this. Save that, and then gotta open the other one. Probably cut this out, but maybe I won't. Anyways, once you get into TrenchBroom, you should see that our red elites is in here now. And if I go in and I run the level, you can see that he is also red in the game. So that's pretty cool. You have your own custom enemy made straight in Blender, no use of any third-party texture baking programs. There is a use of SLK image to pixel, but I think that's a invaluable resource for anyone making pixel art in the first place. And yeah, it's working right in the Quake engine with a custom palette. So I'm pretty happy with this workflow, and I think that it's really elevating the quality of the models that I'm able to make. So in order to get my own custom palettes into the Quake, the MDL exporter, I had to have some, basically some very basic Python programs in place. Just setting the, getting set up with the custom palettes for Quake. I worked with, I used ChatGPT. I don't normally use ChatGPT for coding, but for Python, which I really have no desire to properly learn, uh, I had it write some tedious programs, basically converting a 8 pixel by 32 pixel uh, image, a Windows bits map image of just various colored pixels, sort of in the way that your Quake palettes would appear in Wally or similar pixel art programs. I have a Python script that converts that into I believe it's a um, Pask, whatchamacallit, it's a palette file. So essentially, this is just a basic program. I might put on GitHub or something, but it just reads the RGB data, flips it vertically, and makes this list. What it ends up looking like is I have an output here, I think. I don't have an output here. I have it in here. So this is what the JASC palette looks like. And I believe this one was, I used this format for SLK. And then I needed to convert that to a ACT palette for use in Wally. When I was making some stuff in Wally. So this is, so the ACT palette files you can't really open in Notepad unless there's some special way to view them that I don't know about. But I have another Python program that ChatGPT helps me make that does that. You see, it's really, really basic what that does. Just a small conversion. And then again, it needs to be converted to a Python program for use in this Blender add-on. So you can see they have their Quake palettes.python, and this is basically the same as a JASC palette file, except it's all hexadecimal in parentheses and with commas, and it says Quake palettes or Quake palette equals instead of having that JASC header. So that was a tedious but straightforward conversion to make, to actually get my own palette to appear in the extension. When I go to export, I had to go into the export MDL and MDL.py, and I think also the init, maybe. No, I don't think the inits, but there were a couple of basic, I don't even know how to code Python. It got mad at me for doing crap with the indentations and trying to write else if instead of this made up word, but I ended up just commenting this crap out because I don't use it. But yeah, I wrote pal equals my custom palettes, and I had to make sure to also import that file. And there is one other mention in, I believe it was MDL, where I had to make sure that my custom palette was mentioned. So it was somewhere in here, but yeah, really basic changes that I had to make. And so that meant that I could get that one-to-one pixel conversion from what I have going on in SLK and Wally and Blender. And I think it's important to do the palletizing beforehand, before exporting, just because a dedicated program like SLK image to pixel will do so much better of a job of palletizing an image than something like Wally. If I drag the source image of something like this into Wally, it's just going to be it's going to be a mess. It's going to be really ugly. So yeah, that's the importance of using a dedicated pixel art tool for that. And yeah, so those are sort of the Python programs that I use just to expedite this workflow, because there really is no decent workaround for getting those textures into a Quake model. You can manually replace the textures that are associated with a model using the Quake 1 model viewer, but there isn't a great way of getting images from SLK image to pixel into a Quake 1 model viewer, because it can't take a PNG. It needs a palletized bitmap, and this program, it has a lot of good things going for it, but one of the things that it doesn't have going for it is it can't export images. If I go to save image, none of these file formats are understandable by the Quake engine. None of these file formats have indexed color, so that's what prompted me to make sure that my exporter plugin for Blender was on the same page as me, so I don't have to export in a different color palette and then go in and manually replace that image, because there's really no good program for replacing that image. The only other workflow I could come up with was opening up these PNGs in Microsoft Paint and then saving as a JPEG to get rid of the alpha channel, then opening up that JPEG in Wally and pasting it into a Quake MIP. But at that point, the color has been completely corrupted and it just looks like shit. So yeah, that's the workflow that I'm using, and that's what drove me to figure out this process.